Hello everyone. Today I'll be going over the open-close principle. The open-close principle is the software entities such as classes, functions, modules, etc. They should be open for extension but closed for modification. I'll be getting more into that in a minute. The open-close principle is the O in the solid principles. Uh, if you're not familiar with it, or if it's been a while, in fact, I would just recommend you could pause the video right now and review the solid principles. Google it, find it somewhere, read it over. Okay, so here I have an example. The example has two functions. One of them is a playing music function. The other one is just the main function. Now, I would like you to pause the video again and think to yourself, which one of these do you think follows the open-closed principle and which one doesn't? And more importantly than which one does or which one doesn't is why. Why does it not follow the open-close principle? You can go ahead and pause the video now. All right, so what we have here is we have the main function, which is open to being extensible, but it's closed to modification. There isn't much we can do to these things. Like we can pretty much either delete them or not, and we can extend it by just simply adding another line for a different player. However, when it comes to the play music function, we have, as you can see, we have an if-else block. And this if-else block is taking care of creating all these, let's say, instead of system out print line, we can imagine like in a work environment or something where this is a file with like 600 lines of code. It's a much more complex thing than just simply system out. So to add this, you can't really add anything to this without, right? Without, you see what's going on here? If I want to add the car player down here, I have to go in and I have to actually edit the if-else block. So that's the modification. That's modifying, right? That's do you remember? It should be open for extension but closed for modification. This is the modification part of the thing. You can't change it without modifying it. So that's the issue here. Two record players. I'm looking actually for a car player driving down the road with tunes cranked. Why not? Sounds like fun. And then I can go back here and I can say car player. So what's the solution though, actually, right? I suggest that maybe you could pause the video right now and think about how you could take this if block and make it so that it works somehow in essential elements like this main function does. Okay, so do you have a good idea what you want to do now? All right, so my solution is I'm looking at this and I think this whole thing's reversed. So I'm suggesting that we reverse this, and what we do is we make objects that contain a ability to play music, and then we can create those objects and call that function. So to do this, start by creating a new file. New file will be let's say, a music device, because that's basically what all these things are, right? And there's different ways you can. I'm going to use an interface. So public interface music device, and then this is going to have one function named public, and it's going to return void. Not play music. There. So now I can start creating. I think the first thing I'll do is create a streaming app object. And what I have is public class streaming object, streaming app, sorry, which implements music device. Okay, and so we're gonna do that. We can do a happy little override dealy and say public void play music, requires no parameters. Then I'm just gonna come back here and steal what we already have. And there's my, and there it is. And by creating an interface, I can now replace this, and I can replace it with streaming app, close new streaming app. Streaming app, play music. Okay, there's a couple of things I'd like you to notice here. One is I don't need the parameter. So that pretty much eliminates the need for these default values where it's there just in case, who knows why. Okay, just a second, and I'm going to clean this up, and I'll be right back. Okay, so now what we've done is we've created all three of the objects, and those objects are able to call their own play music methods. So we no longer need this. This whole function here is no longer useful to us. Okay, so the moment of truth has arrived. We have the refactored music player with the main function interface and the objects, including the new car object, which was as simple as just adding the new object. So now we go over here, Java C, music player, I think. All right. Okay. So it looks like it works. We can look at what our music player class looks like now and what it looked like before. Now, I also want you to think about what it would take to test. Now, imagine that these are functions that are calling other functions that are calling a third function. Well, imagine that you update that third function, and now you got to write a test. And the only way you can write the test that calls this private function, and this private function calls another private function and does, and it's like spaghetti code. And the only way you can do that is by running the entire, outer scope of the function, like whatever that is. So now think about it. When you have everything broken down like this, what's your test case? Your test case is probably just to run play music, create a car player, play music. You have like one test case for this class. All it does is call play music and make sure that it's equal to this string. Compare that, because this is the exact same code. I mean, it does the same thing. This code might work, right? You might be able to submit it, and you might go into code review, and it fulfills the requirements of your story. But believe me, if you write this kind of code, your life's going to be much better and happier. I think that's it, and I want to say thank you. If you want more information or supporting information, please see my GitHub repo with the open close principle.